Thank you for joining us for today's webinar, Mapesoil, Improving Sports Surfaces from the Ground Up. We have some brief housekeeping before we start. Your phones are muted. If you have any questions, please type them into the Q&A box in the corner of your screen, and we'll answer them at the end of today's session, time permitting, or via an email after. And you can always send questions to mapeidigital@mapei.com. We also invite you to check out the Products for Sports Flooring page on our website, www.mapei.com, where we have videos, projects, downloads, and more about solutions for sports surfaces, including multi-purpose courts as well as turf. And when it comes to sports surface installation, there are very few people who know more than today's speaker, the Business Development Manager for Mapei's Sports Division, Anthony Graham. Anthony has an extensive background in commercial construction. He's an active member on the board of directors of the American Sports Builders Association. His education, combined with practical experience in chemistry, engineering, and business, give Anthony a well-rounded perspective on the world of sports surface installation. And I know that I always learn so much whenever I speak with him, so I'm really looking forward to today's presentation. With that, I'll let him get started. Anthony, the floor is yours.
Awesome. Thank you very much, Jennifer. Appreciate everybody that's in attendance live today. That we're going to talk about Mapesoil, obviously, our solutions for improving sport surfaces, because as everybody knows, the sub base or the base before you put any kind of flooring or sport surface on is the most important piece. Let's see here. So we're going to do a little bit of basic stuff and then we'll get into the meat of the products. But, you know, what is soil or base stabilization? It's basically the alteration. You're going to enhance strength, permeability. You're going to change the volume stability, the durability. A lot of this is related to plasticity index, swelling. If you're in Texas, PVRs are probably a popular term. That's potential vertical rise. You're going to adjust the permeability. I think percolation, if you're going to do a perk test before you build your house, you need to decide whether or not your soil or your sub base, does it need to be permeable? Do you need it non-permeable? Where are you going to try and deal with that water shedding? And again, soil base stabilization, you're going to change the compaction rate. You're going to adjust, ideally increase the load bearing capacity. It's important because you're going to, again, reduce the system thickness. If you've got really good stable soil, your next layer, whether that's an aggregate base before you're pouring a concrete or asphalt slab, might not have to be as thick based off the geo recommendations. So you're going to limit excavation, maximize your workability. And again, you're just going to improve the soil stability, the strength, the durability, and obviously Mother Nature erosion. That's why it's very important. Why it's important to sports services. Number one is always going to be player safety, but mechanical high load bearing capacity, you got to be able to have other machinery get out there on that field or that sport court, whether or not you're dealing with lighting, you got heavy cranes, machinery like that. You don't want to create divots. Geometric, you want to move that water appropriately, whether or not it's on a track system, your turf field. You got things like infill encapsulation. You don't want that to migrate out. I know that's a hot topic these days. Stability, durability, and again, infiltration rate. Every regional area has different requirements, and that you're challenged to have to meet in the sports construction world. A little bit basic stuff about soil. So anything that really kind of gets over that size of gravel, a couple millimeters, that's not really no longer considered a soil technically. That's going to be a aggregate. And you can have different grades of aggregate, as we know. Once you get below gravel, then you've got sand. That's the next smallest kind. Sand, gravel type soils, those are generally more stable, less changes need to be made to that. When you start getting into silt, clay, even loam type of soil mixtures, that's really when you start getting into where you've got to do some sort of stabilization method. Types of stabilizers, you've got chemical, traditional lime, Portland cement, fly ash being added in. There's also enzymes, chloride used to be one. It's not as popular anymore, polymers. You're kind of changing the chemical nature of the soil of those additives and stabilizers. Then you've got mechanical, whether or not you're just compressing what's there to get it tighter, get it more stable. Remediation, whether or not you're going to bring in aggregate, whether or not it's crushed concrete, crushed asphalt, something else. You're changing the mechanical nature of the soil. And then geotextiles are also very, very popular. Sports fields, synthetic turf, we'll talk about those types of fields and playing surfaces first. The issues you can run in with the base, whether it's the base, the aggregate base, the sub base of that, you can end up with improper slopes, then unwanted water collection sites, erosion, the base layer will move on you, it just creates a rut. It obviously is unsafe and usable. Aesthetically, it doesn't look good. Shorter lifespan of the synthetic turf, obviously, and drainage system failures, which can cause a lot of other issues down the road. With synthetic turf fields, these are the 3 basic tests that are out there. Some of you may be familiar with. The first one, the F1551, that's a comprehensive test of the playing surface and materials as far as the turf and infill combined. It doesn't necessarily include the base. Then you've got just the turf. A lot of that is done there, and then you've got it on the base only. So you've got 3 different types of tests that normally get specified on a designer spec of having to meet these different criteria. So on a synthetic turf field, you generally have an aggregate base layer that's going to be a collection vessel before the water goes to whether or not it's a drainage or offsite or on pond, whatever. So the stability of that, you got to prevent segregation and separation of those stone layers because it's an aggregate base layer. You got to have load bearing capacity and resistance to mechanical movement. So when you have loose stone, it's going to drain really, really well, like as you can see on here, but you're going to have much lower load support. It's going to move on you. You start compacting that, yes, it's going to have more load bearing capacity, but it may not drain quite as well because you're starting to choke it out. So that's sort of like a balance between, so permeability is the ability of soils to transmit water through its layers. Infiltration is the rate. So those terms get interchanged sometimes. Gravels and sands, depending on the type, those are normally what's used underneath the synthetic turf field. Different grades have a higher permeability or a lower infiltration rate and what have you. And again, compaction is the enemy, but you need to meet compaction sometimes. It's a paradox, stability versus permeability. You got your base layers, a lot of times they're specified to meet a 95% standard Proctor. It's not always able to achieve that depending on the materials. So again, paradox, and that's kind of where we come in. We've designed several products that stabilize the different layers. This picture just illustrates just sort of like the layered system typical of a synthetic turf base. We can use Mapesoil RD and SR technology for some parts of this and Mapesoil 100 for other parts of it. Talking about hard courts, running tracks, tennis courts, pickleball, outdoor basketball, if that base layer that's underneath there isn't done correctly, you got improper slope, the asphalt slab or concrete slab you're placing on top of that can shift based off the movement on the bottom. If you've got a high water table, places in Florida, things like that, puddling, bird bass, cracking, all that stuff is an issue. Equipment failure, your net lines, your bleachers, things like that can cause issues if it's not stable. Of course, unsafe, unusable, and tennis court aesthetics is very important. So this is just typical system. You got your subsoil, aggregate base, asphalt base layer, or that could be a concrete slab, vapor barrier or something of that nature possibly in there, depends on the design. But here again, this is where our technology can come in and help make that top layer, that top part, whether or not it's a concrete slab or aggregate slab, stronger, a lot more durable. Product offerings is, we have several. We'll talk about those now. We're a part of a lot of different organizations out there, concrete masonry, ASTM. So we're very much so technical savvy, making sure that our products meet these criteria. The first one we're talking about is Mapesoil 100. It's a fiber reinforced hydraulic reaction binder. It means that it needs water to react, so think concrete in a way. Once this cures and mixed with the soil, it's hydrophobic, a very high CBR value. That's California bearing ratio. We'll talk about that a little bit more in another slide. The product is very fine, so high blane fineness. Think dusty, I guess is the right terminology there. The real nice benefit to this particular product is it can be used in a much shallower application rate instead of traditional lime or cement. That means smaller equipment and a faster install. If you're trying to do like a sports application, you know, we know high schools, colleges, sometimes you got other buildings around, access is difficult. You can't always get giant excavators in there. If you can get in there with a skid steer or a PTO driven tractor thing, you know, we can make this stuff work in a much tighter format. We have our own in-house geotesting lab, so we can test the soils. We'll talk a little bit about that in a second. This product, we can incorporate existing synthetic turf that's on site. We can use non-rubber infill can be tilled in, recycled aggregate, anything that's from construction demolition on site. A lot of times we can incorporate that. So cost savings there, you don't have to have the removal, reclaimed asphalt. We can even take existing clay tennis courts. Say, hey, you guys don't want to play tennis on clay anymore, they want to do a hard court. You don't have to remove that clay. We can stabilize that and then we can cover the top of it. Comes in super sacks, and we can do a couple of different kinds of loading, whether or not it's bulk or on-site bazooka loading, if possible. Again, that ties into that access and smaller equipment that works out better. So the Mapesoil 100, the chemical features, it really depends on the soil. So we always have to test the soil every single time. We got to know what the soil classification is. That's an A1 through an A7, and then there's like a few subcategories there. Basically, the really nice soil is like A1 through A3, A4, and then you start getting into those higher numbers, and it's a little more difficult. A lot of times a higher dosage rate, or even you still have to add remediation into the soil before you can even treat it with lime cement or Mapesoil 100. We test compaction curve. You know, this helps us figure out what the optimal moisture content is. Again, it's a hydrolysis reaction. We've got to add water to it, just like concrete. We know the exact amount of water that works with Mapesoil 100 by itself, but when you're mixing it with all these different soils, that changes. So we've got to make sure we give you the right recommendation. And then the CBR index, that just basically helps us make sure we dial in the exact dosage and not overdo it for you. Here's the different soil classifications talked about. Again, A1, A2 through A4, normally pretty good stuff. Easy to deal with, low plasticity, low liquid limit. It works out very well. You get into the A4s, the A7, 6s. That's generally clay. Think red dirt, loose sandy loam soil, stuff like that. Compaction test, we mentioned that a second ago about the optimal moisture content. It just helps us here. This is one of our machines. Again, we can take care of all this in-house. CBR index. So CBR index, California bearing ratio, that is used pretty broadly. Again, if you're in Texas or kind of in the middle of the country, I think you're going to hear the term PVR a little bit different because you're worried about potential vertical rise. So that's a different test, but we can also test for that as well. Just for your reference, CBR, it's based, the scale of CBR 100 is crushed limestone. That's the standard. So minimum, you always want to get to an 80 to 100 when you're doing a base before you put down, you know, another layer of aggregate, or if you're going to pour a slab of some kind. CBR 3, think tilled farmland, really loose, like, you know, really loosened up bag of soil. Natural turf or moist clay, you know, is going to be a 4 to 5 range. Moist sand is a CBR of 10. So think about a sand castle. You know, it'll stay there. You don't have to apply a whole lot of pressure for it to move, but it will hold its form. And then you get into the 80s, 100s. Typically, almost every single recommendation we make with Mapesoil 100, we target a CBR index of 150 or higher. So we're looking for something that's super strong. It's going to be there for a long time. You're not going to have to worry about it. Water's not going to affect it. And it's a lot easier to install. Mapesoil 100 again, works great. Just don't ask us for a core sample. This was some red clay that we stabilized at a job site, and trying to do a diamond drill bit, cut it out. As you can see, it's quite difficult. Moving on one of our other products, Mapesoil RD stands for rapid drain. It's again a hydraulic binder. This is going to mix with aggregate. So this isn't necessarily for native soil like what we would test before. We don't have to do a lot of testing with this. You just let us know, hey, this is the size aggregate I'm putting down. This is the drainage system I'm looking for, and we can make the right recommendation. You're going to mix this basically in a mixing vessel, concrete mix or something like that. You can put this down almost like an E layer. Like as you can see up in the picture of an SMG paver type machine, goes down just fine like that. Depending on where you're at, if you're above the snow belt, below the snow belt, high humidity, low humidity, whatever, we can make some enhancements to that with very small additives. Also, we can control the plasticity. So this is a very nice product that we do in golf bunkers that help keep the sand in place and also help keep the infiltration rate high. That way those bunkers don't get too soggy or too puddled. The golf course doesn't have to close down that hole or whatever. Golf maintenance guys love it. Highly permeable, highly stable. Works with angular stone very well. It can also be used with circular stone, like pea gravel type size stuff. We can use it to move it with concrete spray pumps, paver machines. It's a very nice, versatile product. Works on a wide range of aggregate sizes. Then Mapesoil SR, a sub-base repair, is what that stands for. This is a very similar acting product as the RD, but it's used for aggregate that's already in place. So let's say you've had a lot of movement, you got a big, large area, this one part of the field just seems to get bogged down, keeps moving, whatever. You go back in, fill in your stone. You can spray this on top of it, and we have, depending on the dosage rate, you can either lock it in and still maintain all of your permeability, or you can lock it in and choke it out, essentially flood it, and it becomes almost like a solid concrete pavement surface. Easy to apply with water, mixes. If you're going to do a large job site, hydro seeders that are easy to rent, those are perfect. And we can tailor make this product, whether or not in 50-pound bag, or if you do rent a larger application machine like a hydro seeder, they come in a range of 400 gallons all the way up to, I think, 2,000 or 3,000 gallon size. We can make a super sack where it doses into that tank all in one shot, so you're not loading a bunch of different bags. You got multiple guys out there, it gets messy. And then we also have a Mapecrete system, kind of fits in the same realm, talking about Hardcourts. Again, this is for concrete. A blend of admixtures, Dynamite, Expandicrete, these are super plasticizers, fiber reinforcement, shrinker reducers. It's a perfect little blend there, and it basically takes the place of post-tension. It's pretty interesting stuff. We limit the number, or just completely, we either eliminate or limit the number of expansion joints. Makes the installation a little bit easier for those guys with the squeegee on the tennis coatings. Obviously a longer life. And we have the ability to load at the concrete quarry site, so you're getting like a complete mix that's delivered ready to go, or we can do the additives dosed at the supplier site in the concrete jar while we're there. So that's about all for how we can, this is just a little taste of the things that we can do to help keep the sports surfaces, your synthetic turf, your acrylic coating, stuff like that, in prime and preen condition. If you welcome any questions anybody may have.
All right. We do. Thank you very much, Anthony. Let's see. Our first question. How do I know how much of any one product to use? Oh, that's a good question.
So if it's one of our aggregate stabilizers like the Mapesoil RD or the Mapesoil SR, we're going to have recommended dosage stuff on our tech data sheets. And if you have something that doesn't quite fit or doesn't fit in that peg that's listed there, you can always reach out to us. And we can do a quick test, or we may already know, we may already had experience doing it. Mapesoil 100, we always test the soil. It doesn't matter what the job site is. You can test soil in one area, walk a couple hundred yards, and it's a completely different thing. So we always recommend doing lab testing with that, and then we'll make a recommendation based off of that.
Gotcha. All right. Here's another. What is the thickness of the PT replacement product?
It depends on your slab. So we can do, I think typically we do 6 inches, depending on how wide, like how large of an area you want to do that slab. It could be shallower. It could be 4 inches instead. Just depends on what you're doing. There's a big difference between doing like 2 or 3, say, tennis courts. A tennis court's 7,000 plus square feet, or if you're going to do a shuffleboard court. So those slab thicknesses are going to be different. So we can do either one.
Right. Follow up. Okay. So is there any steel in that product?
I'm sorry, what? Any what in the product?
Is there any steel in the PT replacement product?
I do not believe so. No, no steel. No rebar, no post tension, no rebar, no netting of that kind.
Gotcha. All right. Oh, here's another good one. How long before we can install over an application?
Typically, all of these are going to be the next day. Mapesoil 100, it's going to be environmental. Like if you did a Mapecrete slab, you're going to treat it the same way as a concrete slab. It still has to cure properly. Mapesoil SR, Mapesoil RD, very much so very next day, 24 hours, you should be able to get back on top of it, no issue. Mapesoil 100 is generally the same. Again, it depends on the soil type, and also the weather, if it's rained. If you install Mapesoil 100 and then it rains, then you're gonna have to wait another day. But generally 24 hours on those.
Good question. All right. Ooh, here's a scientific one. What if I don't care about the permeability and just want to lock in a soil layer or a stone base?
If you just want to lock it in, the Mapesoil SR is probably the best product because you're gonna flood it out. If you don't want permeability, you're choking the system essentially. So that would be my first recommendation on that. Again, if you have a very high plasticity soil, we may need to look at maybe using Mapesoil 100 instead.
All right. Well, okay. What is the main difference between SR and RD?
The main difference, so RD stands for rapid drain, SR subbase repair. Hopefully I answered that question properly.
Is there a follow-up to that? I'm wondering, like, do you mean when would one be used over the other? Let's see.
If that's the follow-up question using one, so SR is going to be stone that's already there, so existing. You've already put down your stone layer, you've got your planarity where you want it, and you just want to lock it in. RD, you're gonna put down a thickness, or you're gonna decide, hey, this is how thick I want the stone layer to be, and I'm going to lock it in this different method while I'm putting the stone down. And again, that one's a little bit where you can adjust the plasticity of it, so you can do slopes with it and create mounds. You got undulations. It's a lot easier to deal with, where if you got loose aggregate that's just kind of not quite compacted very well, it's hard to lock that in another method.
Both systems allow for drainage?
Yes.
Okay, there you go. Interesting, very interesting. Well, let people think of a few more questions here while we kind of wrap things up. And I know, thank you, he says thank you. I know if people are anything like me, and I imagine they are, the questions always come about 5 minutes after we say goodbye. So if that's the case, then please do send your questions to the email address on the screen, mapeidigital@mapei.com, and we will be sure to forward them to Anthony, and he will be happy to answer them. And if there aren't any more questions now, I will go ahead and wrap this up. And before I do, actually, I would like to remind everybody to please go and visit the sports flooring page on our website, and that's www.mapei.com, because we do have a lot of information there, including information about the Mapesoil family of products. Okay, with that, I will conclude today's webinar. Anthony, thank you so much for a wonderful presentation. And thank you, everybody, for joining us. We know that your time is very valuable, and we really do appreciate that you spent some of it with us today. We will see you next time. Have a great rest of your day. Thank you. Bye-bye.